Hey, this is Don from Padlock Technologies again with another video. This time we are going to talk about SD-WAN, or modernized SD-WAN as I call it, because this is another use case for Cisco Secure Access or Umbrella SIG. If you're an Umbrella SIG customer, you can do this as well. But my preferred method would be Cisco Secure Access because that is the better SASE solution. Now, better is subjective depending on who you ask, but to me, Cisco Secure Access is the better solution. So you've seen this lab a bunch of times in my other videos. We're going to focus on this piece down here. Now, this lab that you're seeing is kind of a hybrid or an advanced lab here. What I mean by advanced lab, well, you see there are three V managers. There are two controllers slash vSmarts, and then there's two vBonds. All right. So this deployment that you're getting ready to see is called multi-tenancy SD-WAN. This is for someone that is a co-managed SD-WAN provider that manages clients like ourselves. If you want to take all the expertise of SD-WAN, you probably don't have that on staff, and you don't have time for someone to learn it and learn through trial and error and probably bring down your network a bunch of times before they get it right. You would come to someone like us, and then you would come in our environment, or we would make you a tenant in our environment, and then we would just manage your SD-WAN for you. If you're looking to get something like that, there's going to be a link in the description below for a discovery call. We can talk about getting you in our environment and managing your SD-WAN for you. So what this looks like here is these three managers are in a cluster, basically one cluster. And if you look at Cisco's deployments, they kind of do this three node cluster in ACI. They do it in DNAC. They do it in SD-WAN. They always want to do three because one's going to be a tiebreaker, obviously. And then you have your two vSmart controllers. Now, in this deployment style or in this configuration, I could have had as many controllers as I wanted. The more controllers I have, the more tenants I can put. But I think two controllers can give you upward to, I think 250 tenants, I believe. Don't quote me on that. In the documentation, I think it's 250, but only have two. So in this deployment, you're going to see two tenants. They're not real tenants. It's MGM Casino and Mandalay Bay. Now, you're probably asking, why did I pick those? It's because when I built this environment, I was staying at Mandalay Bay, and I was in the MGM casino in Vegas for, I think, CSX. And I had this idea, and I was like, let me lab it out and just make sure everything works the way it's supposed to. So this is the culmination of all the stuff that I was doing. Now, I know you see over here, Cisco, you may see at the bottom here, it says Palo Alto. So don't be mad at me. I still love Cisco products. I deploy them more than anything. And like I said before in my previous videos, I deploy other firewalls, Palo Alto's being one of them, but I still love FTDs. I've deployed Palos, Fortinets, checkpoints, WatchGuards, Sonic Walls, Juniper SRXs, Screen OS before they became SRXs. So I've been down the road when it comes to firewalls. I'm just doing this to simply get some internet connectivity, some public firewalls. I'm doing netting here just to make sure you know the concepts. Now, why my VBonds are, what do they call these validators? Why are they given outside IP addresses? Because they have to. Now, in the documentation of Cisco, they will tell you that the validator slash VBonds are the only thing that need public IP addresses. That is completely wrong. Every everything in your environment, vmanagers, vSmarts slash controllers, and vBonds need public IPs. And I'm going to show you why in a second. Just long story short, when you connect a C edge or a V edge, if you're using Viptela, when you connect that to the fabric, it will give the IP addresses of the vManager and vSmart whatever it used to connect to it. So if it uses the private IPs to get there, it will send the private IPs to the C edges. And now your C edges or V edges can't get onto the fabric because they don't know how to get to private IP addresses. That's why you don't do that. And I'll show you in the lab here when we get into one of the C edges. I'll show you what the controllers is, or the control connections are. So we got retail 2. Again, SD-WAN is perfect for retail environments or people that want to have a back-end tunnel or dynamic tunnels, and they don't want to really put a firewall in play. Now, the reason why I say don't put a firewall in play, because again, I am overlapping this with Cisco Secure Access. So all my firewalling, so to speak, is going to be done in Cisco Secure Access. Videos on Cisco Secure Access will be coming soon. Just looking to get some things on the back end. And then once I get that stuff, I will show you the back end and how this can actually modernize your SD-WAN deployment. So here we go with these are going to be the MGM casinos, the retail 1 and 2, and then obviously these ones up here that say MBs in Mandalay Bay. I don't have them turned on yet, so you won't see anything in there. So now let's go to the SD-WAN controller or the vManage, and then let's take a look at everything that's going on. So let's pull this up. So as you can see, we are in the provider console, and you can tell because it says operating as provider. You will not see this if you do not do multi-tenancy in SD-WAN. You will just see one console for your fabric. Since I'm a provider, since I can do manage SD-WAN services, I built this so that, hey, if I wanted to bring you on as a client, and again, this is a lab, but this stuff is easy to build on the back end. If I wanted to bring you on as a client, I would make you your own tenant, and then we can control your SD-WAN, or we can manage your SD-WAN. And no matter how many clients you have, all that routing configuration information is kept separately. So nobody can leak in between different tenants. So what we're going to do is we're going to go to the MGM Casino tenant, and then you're going to see everything there. Now, the only thing here you're going to see is validator, controller, managers, because this is the provider part. I don't have any devices configured here, so you won't see WAN edges because I don't have a fabric for just the provider. That's why you don't see anything here. So now we're going to click this down arrow. And as you can see, here's my tenants. MGM Casino, Mandalay Bay. Great places, by the way. Cisco, you need to do CSX again there. So we're going to go to MGM Casino. Now, what this is going to do is kick me out of the provider. Then it's going to go into MGM Casino, as you can see. And now I'm going to see stuff here. So let's give this some time here. We're going to see certain things pull up. So once this kicks me out, now this looks like the provider because it didn't switch over yet. So once it switches over, you're going to see all of this disappear. You're going to see validator, controller, manager disappear. That literally just happened on cue. I did not guess that. That literally happened on cue. And then you're going to see this number that says 0 reachable. That should turn to 2. There you go. And that just happened on cue. So I think I might need to play the lottery. Excuse me. So you're going to get some information here. And I don't know why that just came up. But you're going to get some information here about the site. So I have site 4 and 5 that correlates to, excuse me. Retail 2 is site 4. Retail 3 is site 5. Excuse me, I don't know what happened there. And then you see the WAN edge health. And then you see the status there. So now let's look at a little bit more detail. And you're going to see devices. All this should be green. And you see the site IP, our system IP. This is numbers that you have to, it's basically like a loopback address if you want to really look at it. That just identifies the site, or it identifies the device in a site, because you could technically have 2 devices in the same site and the ID would be different. And then when you look at your OMP routes, it'll tell you, hey, you can get to this network behind this device or this device. And that's a whole T-lock thing. I can get into T-locks later. Then you got your tunnels. Now, these are going to be your OMP and your dynamic tunnels through SD-WAN. And then you're going to see this SIG SSC tunnels. This is if I had Umbrella integrated in. Then you'll see these tunnels going to Umbrella SIG. Now, because I'm not doing it to Umbrella SIG and it's going to Cisco Secure Access, you're not going to see anything here for that. So now we're going to go into one of the boxes. How you get there is through tools and SSH terminal. And this is how anybody, if they wanted to get into a box and actually run some commands here, this is how you do it. And then you're going to click on one of the boxes here. And it's going to bring up basically a console, and it's log in here. Now, normally I would never make the passwords this simple. Because this is a lab, I really don't care. So let's start talking about VPNs and how SD-WAN kind of works from a data plane standpoint and control plane standpoint. We'll talk about that as well. So they're VPNs. So VPNs are technically VRFs on iOS XE. So these are your ISR routers, these are C8000Vs. So they're going to be considered VRFs. Now in V-Edges, which is the old VIP devices, they're VPNs. So there are two VRFs or VPNs that are, built in by default. There's VPN 0, which is your internet underlay. It's how you basically get to your ISP. The tunnels are built on top of that. And then there's VPN 512, which is your management VPN, which is if you wanted to do TACX or something like that, you would put an interface in VPN 512. And then that separates the underlay because you can't see the routing tables because they're separate VRFs. And then everything past that is a service VRF. So you could have VPN 1, 2, 3, 4, whatever. And those are going to be service VPNs. Those are the VPNs that initiate or help you get the site-to-site connectivity because those routes are going to be redistributed into OMP, and then they're going to be redistributed from OMP into whatever routing protocol you're using if you're doing that, or if you got a default route, just go into the C-Edge and knows how to get there. So what I'm doing, I am doing OSPF here. There, you can do EIGRP and SD-WAN depending on the version, but I'm doing OSPF here. And I'm redistributing my OSPF routes in the OMP and by mutual redistribution. So what we're going to do first is we're going to validate the routes. So if you just want to see the global routing table or VPN 0 underlay, you just do show IP route, and you're going to see the single static route here that is going to the ISP. And then if we want to see the overlay routes, when the service VPN, you have to do show IP route VRF, because remember I said VRFs are basically VPNs. So this is technically going to be VPN 1, but it's VRF 1 on the CLI. You hit that, and now you're going to see, you hit enter, and you see a bunch of routes here. So you're probably asking, all right, let's talk about these routes. What are these routes? So anything you see in BGP is coming from secure access. This is the modernized SD-WAN that I was talking about. So all my firewall functions are handled in secure access. I do not have a firewall. If you saw the lab, it's just a router there. There's no firewall function on that router. There's no zone-based firewalling, which is an old school firewall for routers. That's no technique there. So I have a static route coming from secure access because I know it's from secure access because you see this weird non-routable address here. Well, secure access has two addresses and they're /30s and they're in this range. So I have this peering going to secure access via BGP. And then I'm getting a bunch of other routes from BGP. So I'm running VPN as a service as well. So these are a bunch of VPNs as a service route. So basically if I had resources behind this site and I have RA VPN running, I can technically get to that through this site, and then the site knows how to get back to the RA VPN as a service users. But I'll show you that in the next videos. Once I start showing the secure access videos, this will all make sense. Just know it can be done. Anything that's BGP is technically coming from secure access. So again, in secure access, you have two ways to do backhaul tunnels, and that's the first thing you need to create. It's BGP or static routing. I decided to do BGP because I want to take care. I want to do that dynamic routing, so I don't have to worry about not having to do static routes. So, I forgot a static route here, and now I lose connectivity. So you don't want that. Then the next thing you're going to see is these M routes, which are OMP routes. Now, these are the routes that you're seeing through the dynamic tunnels that are created when you onboard a device onto the fabric. Once you do the redistribution, or it's a service VPN. So once you do, I'm doing OSPF. So technically, them M routes are OSPF routes that are at the site. We are on, retail 2. So these M routes, this is the point-to-point link on the other side, which is, 10.1.102/31. and that's the point-to-point link between the switch and the router. And then behind the switch, or a SDI on the switch, is this route here, which is 172.16.3.0. Now 2.0 is local to me. So that validates that SD-WAN is up and running, the tunnels are up and running, and I can see the routes. Now, how does that actually look from a SD-WAN perspective though? So if I go show SD-WAN OMP routes, this is going to take some time to generate, but these are the OMP routes. So as you can see, these are all the routes that I am getting through the fabric, right? And this is how you see how it's installing it. These are all the routes there. Now, some of these are going to be BGP. Some of these are going to be coming from the dynamic tunnels from the other site. Now, the thing that I told you last time about, hey, you got to make sure everything has a public IP address. So why is that? So the first thing we're going to do is we're going to look at our OMP peers, which will be the vSmarts and controllers. So we do show SD-WAN OMP peers. Now we do the peers, you're going to see these are the vSmarts. These are the two vSmarts. The peer IP addresses are the system IPs of the peer. So one's 4.4 and one is 0.5. But that's not where I wanted to point you to. I'm just going to show you that I do have connectivity to the vSmarts. If I wanted to do some type of route manipulation or, policy-based routing or application-based routing, stuff like that, I could do it. Now the next one here is you're going to show SD-WAN control connections. All right. So we look at the control connections here. Now, this is where you have to be careful and you have to make sure that everything has a public IP address. Because if you see it here, and this is how you get onboarded to the fabric after you authenticate with the validator / VBON. The VBON, our validator, sent this information over to each C edge. So if I was only connecting via the internal IP addresses, it would have sent just the private IPs that you see here, and then my C edges would have never connected to the vSmarts or the vManager because it doesn't know how to get to a non-routable IP address. This is why in the documentation they just say VBON needs a public IP address. That is not true. Do not do that. If you're going to try to build this yourself, everything needs a public IP address. Everything needs a one-to-one NAT, period. That's the best way to do it, because if you put it behind just a PAT kind of thing, it's, from a management standpoint, it's a little difficult to do. So with that being said, everything is here. We're going to go to one of the machines there. We're going to log in. I'm going to show you just a simple IP chicken to show you that the IP address that you see in IP chicken is not the IP address in my house. It's actually the IP address in secure access, and that's how you're getting out to the internet. So let's pull up a machine here. I'm going to log in. And this is someone I used to work with here. Great engineer, Jonathan. Hope you see this video and start laughing. I had to use you as a user in my lab. So now let's open up a Google Chrome, and all I'm going to do is do simple IP chicken. And then once you see the IP address, you're going to see that is the NAT coming from secure access. And basically, when you want to have internet access from secure access, it basically puts you through a NAT. If you want to learn more about just from a theories perspective of secure access, I'll put the playlist at the end of this video, and then you could just, learn from a theory perspective how secure access actually works. So let's click on this here. Not sure why this was taking so long. So now let's just do IP chicken real quick. IP chicken. Let's go here. And as you can see, this IP address here, 151.186.183.80 is the IP address, or the NAT IP address, that I am getting from secure access. And If you really you don't want to know, I'll do it on my own machine here. Now I'll just do IP chicken. As you can see, that's my home public IP address. This is my lab in my house. So that validates that this is actually going through secure access to get to the internet. So this is how you modernize your SD-WAN, right? Because typically, if you wanted to do internet access directly off of the WAN edge or the C edge, you would do something called DAI, which is direct internet access, which has no security function whatsoever. It's just raw internet coming in and out behind the net. And I'm gonna just say flat out, net is not a security mechanism. It wasn't built for security, and it's not security. Um, I don't care who you ask. I will die on that hill. That is not a security function. Now, some people will say security based is a security function because of obscurity, but again, that wasn't the purpose of NAT. It wasn't built for that. So just be careful who you listen to if they say NAT is a security function, because it's not. And we can argue for days in comments. I'm telling you, it's not a security function. But I'm off that soapbox. So, but this is going to secure access. Now, secure access now gives me more functionality. Like what? It gives me SSL decryption. Now I can take that whole SSL decryption function, take it off box, so I don't have to worry about it bandwidth hits. I'll take it off box. And now the cloud's doing my SSL decryption, which is a lot faster, is more processing power, and I can, do malware inspection. I could do IPS and secure access. I could do everything that a normal firewall can do, but only in secure access now. I have more compute power using secure access than doing it on the box, right? It's the same thing you saw some of my firewall labs. I can do a tunnel up to secure access, move that SSL decryption function and IPS malware function off of the box if you wanted to do that, and have secure access do anything or everything. So that was a brief look at modernized SD-WAN. Again, modernized SD-WAN is SD-WAN with SASE over top of it. And some of the features, some of the use cases, we got to validate certain things in the fabric. If you are looking to potentially work with us because you like what you saw here and you want us to do this type of stuff for you, because we just don't do this type of stuff. We do firewalls, we do ice, we do normal routing, we do secure endpoints, all kind of stuff, umbrella sig, secure access. We do all kind of stuff. If you're looking to kind of modernize your environment and keep it secure, you need to hit the links in the description and get a discovery call. Now, the discovery call, we can't sell you anything on the discovery call because we don't know anything about your environment. So I'm not just going to start throwing out solutions without actually knowing where you are and where you want to go. And we can plan out how to get you there. Once again, this is Don from Padlock Technologies. Hope this video was informative. Thank you and have a nice day.